Somewhere in the universe, a bubble might already be expanding at the speed of light. And if it is heading toward us, we will never see it coming, because the light that would warn us and the thing that would erase us are the same wave, arriving at the same instant. For most of the last century, that was pure speculation. Then, in 2012, an experiment in Switzerland measured a single number and quietly suggested it might not be speculation at all. The number was the mass of the Higgs boson, about 125 gigaelectronvolts. The discovery made headlines as the last missing piece of particle physics. But buried inside it was a second result the press releases mostly skipped. It told us our universe may be sitting in the wrong energy state. Not as a metaphor, as a specific, calculable claim that the vacuum of space, the empty background everything else is built on, might not be as permanent as it looks. To see how one number could imply the end of everything, you first have to know what the Higgs is actually doing.
The Higgs field fills all of space. It is the reason particles have mass, the reason electrons are heavy enough to bind into atoms, the reason chemistry and you exist. And like anything in physics, it settles into the lowest, most stable place it can reach. Picture a ball rolling to the bottom of a valley. For decades, physicists assumed the Higgs field was already at the bottom. There was no reason to think otherwise, and no measurement precise enough to check. The 2012 discovery finally let them check, and the answer was not the one anyone was expecting. Once the Higgs mass was pinned down, theorists combined it with another value they already knew precisely: the mass of the top quark, the heaviest particle in the Standard Model. Those two numbers together fix the exact shape of the Higgs potential, the shape of the valley. When they drew it out, the ball was not at the bottom. It was resting in a smaller, higher valley, stable enough to sit in, but not the lowest point. Nearby, behind a barrier, was a second, deeper valley, the true bottom. And our universe was not in it. There is a word for this: metastable. Stable until it isn't. Independent teams ran the calculation, most famously a 2013 analysis by Butazzo and collaborators, and they kept landing in the same uncomfortable place. Our universe sits almost exactly on the line between stable and unstable. Of all the values these masses could have had, ours put us right on the edge. No one knows why. That coincidence is one of the strangest results in modern physics, and it falls straight out of real measurements, not theory alone. Which raises the obvious question: if we are in the higher valley, can we fall out of it?
In classical physics, no, the ball can never climb the barrier. It would sit there forever. But the universe is not classical. It is quantum. In quantum mechanics, a field can tunnel straight through a barrier it could never climb. It is rare, almost unimaginably rare. The number physicists quote for the lifetime of our vacuum is around 10 to the 100 years, a 1 followed by 100 zeros. The universe so far has lasted about 14, followed by 9. So we are safe, overwhelmingly, comfortingly safe, on any time scale a human, a civilization, or a planet will ever care about. With one asterisk: that number assumes the Standard Model is the whole story. If there were particles or forces we haven't discovered yet, the true lifetime could swing by many orders of magnitude, longer or shorter. And 10 to the 100 years is still not infinity, which leaves the one question the math refuses to make comfortable. what exactly would happen if it did?
Here is what the theory predicts, and it is not vague. A region of space smaller than a single atom tunnels into the deeper valley. Inside it, the Higgs field has a new value. Particles have different masses. Atoms, as a structure, no longer work. For an instant, the field's surface tension tries to collapse the region back. But past a critical size, one you can calculate directly from the shape of the potential, it does not collapse. It grows. And the wall of that bubble expands at the speed of light. The equations are unambiguous about this. The transition moves at the fastest speed anything in the universe is permitted to move, which means there is no faster signal, no warning shot, no early light. If a bubble formed 1 billion light years away 1 billion years ago, the first photon we ever received from it would arrive at the same instant the bubble did. You would not see a flash and then feel it. The seeing and the ending would be the same event.
And what it does is not violence. It is replacement. Your atoms would not be blown apart. They would simply stop being atoms. The rule that lets a proton and an electron hold together as hydrogen would no longer hold. The sun, the earth, your body, rewritten in the time it takes light to cross from one side of you to the other. About 10 nanoseconds. This is not fringe science. The bubble dynamics come from Sidney Coleman's 1977 paper on the fate of the false vacuum, one of the most cited works in all of quantum field theory. The masses come from the LHC. The lifetime comes from peer-reviewed calculations. And every one of those calculations still says the same reassuring thing. Not soon. The odds of it happening in your lifetime or in the next 1 billion years are effectively zero. There is no evidence that a transition has ever begun anywhere. The bubble is real on paper, and as far as anyone can tell, only on paper. The reason physicists can't quite let it go isn't a fear that it's coming. It's that we never expected to find ourselves balanced on the edge at all. The Higgs mass could have been anything. It landed on the line. And that is what the 2012 measurement quietly revealed. Maybe the strangest mercy is the one thing the math is sure of. If we are ever wrong about how safe we are, we will never find out. The end would arrive at the speed of light, carrying its own silence. Next video. There are more planets drifting through this galaxy with no star at all than there are stars for them to orbit. Entire worlds in permanent darkness. And we only found them by accident.